Okay, so we talk about how to use reinforcement learning approaches on intrusion detection systems. Um, Here I will focus on how to transfer detection tasks to the reinforcement learning task. The table shows the transformation. The state is the data in the dataset, and the action is the prediction of the agent. And the agent is the classifier. If the prediction is right, then the reward is 1, else it is minus 1. Here, episode we can define by ourselves, and we can define length of episode by ourselves to evaluate the performance of the agent. Here is the interaction stage inside an episode. This is the whole process of interaction stage. Starting with the dataset or data in the dataset can be considered as the state, and the dimension of the state is 122 after pre-processing. When an episode is launched, at first we randomly sample a state from a dataset, and the agent make a prediction of the current state, and then compared with the label, we can obtain the reward. And then we can use the sample agent to generate the next action, and the sample next state belongs to next action. And we can store state, action, reward, and the next state pair into a replay buffer. Here we use there are many online datasets for intrusion detections. In our experience, we use NSLKDD, which is a very classical and traditional data set. After one-hot encoding, the dimension of the state is 122. So next, here replay buffer is advanced tips for training Q-learning. So if the buffer is full, then all data will be replaced by some new data. So mm, at the beginning of the episode, we can randomly sample a state from the dataset, and the first one begins with this stage. But in the following stage, except the first stage, the following states are sampled by sample agent. If the current state is now reaching the end of the episode, next state is sampled by sample agent and stored to replay buffer. But if the current state is the last state inside an episode, then we don't need to sample next state here. A new state is random sampled from the dataset and a new episode is launched. So here, introduction, what is the episode? Here we can decide the length of episode by ourselves and use episode reward to evaluate the agent. And the sample agent is a kind of adversarial training edge with the main agent. The only difference between the agent and the sample agent is the reward mechanism. If the prediction of the agent is wrong, then the reward is 1. Otherwise, it is minus 1. We can use the sample agent to hope that those state action pair which are wrongly predicted by the agent can be sampled more frequently. So this is the whole training stage. Right part is the main agent of our network. We can use at first we preaching a stacked autoencoder to implement dimension reduction. Then we use the encoder to be the main structure of the agent. The first three layer is shelled, and an additional soft mask layer is added for classification, and another soft mask layer is added for the sample agent. The agent and the sample agent can share the first three layer as the first, because the first layer is basically used for feature learning. So agent and the sample agent are chained parallelly. Update network is updated through backpropagation. Target network is initialized with the parameter of update network, and updates are made every n times through copying the parameters from update network. So here is the exploration. Epsilon gradient algorithm is applied to the same sample agent, and epsilon controls the exploration level. This is a widely used exploration approach in Q-learning. Another exploration approach is conducted by conditional gap. Because we think a fixed data set is not appropriate for simulating a complicated and ever-changing network environment. So by means of conditional game, we attempt to generate some novel attack flows belong to each label. This is also an approach to solve the imbalanced dataset problem. And the conditional GAN takes the label and noise as the input and output state belongs to the label. Actually, if we have a good data set, we can use a GAN to simulate a more realistic interaction environment. And this is the performance on the validation data. This is validation accuracy, and this is absolute reward. So we can see that most of the value pair can reach high and can achieve high performance. Thank you.